Have you ever wondered about the future of hydrogen-powered engines? Well, interestingly, recent trends and initiatives are making it clear that this future isn't as far off as you might think. Let's take a look at the Airbus Zero initiative, for instance. Airbus has unveiled plans to test a hydrogen-powered fuel cell engine on a modified A380 Super Jumbo. The engine uses fuel cells to convert hydrogen into electricity, which powers a propeller. The goal? To launch a zero-emission aircraft by 2035. And it's not just in aviation. In the rail freight sector, Australia's Aurizon Holdings Limited has teamed up with Anglo American plc to explore the development of hydrogen-powered trains. They're conducting a feasibility study to assess the use of hydrogen fuel cell and battery hybrid power units as a replacement for diesel engines. Hydrogen is being considered a sustainable alternative to traditional fuels, despite challenges such as low energy density and infrastructure requirements. The potential is there, and the next decade will likely determine the viability of hydrogen technologies for low-carbon travel. As we can see, the future of hydrogen-powered engines is both exciting and filled with potential. How do hydrogen-powered engines stack up against traditional engines? Let's delve into that. Hydrogen engines are energy efficient, offering 3 times the specific energy or power-to-weight ratio of gasoline. That's a significant advantage. However, hydrogen's lower density means it takes up more space. For example, a gallon of liquid hydrogen weighs just 0.6 of a pound, compared to gasoline's 6 pounds. On the environmental front, hydrogen shines. It's a clean energy source, emitting only water vapor when burned. Traditional engines, on the other hand, emit carbon dioxide and other pollutants contributing to climate change. But it's not all rosy for hydrogen. Infrastructure is a major hurdle. Hydrogen fueling stations are few and far between, unlike the ubiquitous gas stations. And storing hydrogen is a challenge, due to its low density and the need for it to be cryogenically cooled to below -400 degrees Fahrenheit. Companies are exploring solutions though. Kawasaki, for instance, plans to use pre-filled cylindrical canisters to store hydrogen on its hydrogen-powered bike. But this method does limit luggage space. While there are challenges to overcome, the benefits of hydrogen-powered engines make them a promising alternative to traditional engines. To recap what we've learned about hydrogen-powered engines, we've seen how they offer a promising path towards sustainable mobility. Hydrogen as a zero-emission fuel has the potential to significantly reduce the carbon footprint of the transportation sector. Companies like Airbus are pioneering the use of hydrogen fuel cells in aviation, with ambitious plans to launch a zero-emission aircraft by 2035. In the rail freight sector, Australian company Aurizon is exploring the use of hydrogen-powered trains for bulk freight. And let's not forget the big 4 Japanese motorcycle manufacturers, Kawasaki, Suzuki, Honda, Yamaha, who are jointly developing hydrogen-powered engines for small mobility vehicles. However, there are challenges to overcome. Hydrogen has a lower energy density than traditional fuels and requires larger storage volumes. This has implications for vehicle design and infrastructure requirements. Moreover, the transition to hydrogen power isn't without its skeptics. For instance, some experts question the feasibility of large commercial aircraft being powered electrically. But despite these challenges, the initiatives and innovations we've discussed today demonstrate a clear momentum towards a hydrogen-powered future. The future of hydrogen-powered engines is full of potential, and it's a future we should all be excited about.